When the same AI agent performs worse, check context and runtime settings first. This episode gives you a screenshot-ready model, context, runtime checklist for deciding when to repair the workflow and when switching models is actually justified. In July 2026, OpenAI revisited GPT-5.6 Sol on the ARC-AGI 3 public task set. The same model scored 13.3% in the official generic harness and 38.3% with retained reasoning and compaction, while using about 6 times fewer output tokens. That result is limited to one model, 2 API settings, and 1 public task set. It does not mean every AI task will improve threefold, and it does not replace your own acceptance tests. This video is packed with practical, high-value insights to help you get better at using AI. It's a longer one, so follow Tiny Agent and save it so you don't lose it. First, unpack the phrase, "the model is bad," so you can see that performance comes from the model, context, runtime settings, and acceptance method together. The model supplies baseline capability, but visible history, tool access, retained state, and long task context management also shape behavior. ARC-AGI 3 asks agents to explore unfamiliar 2D games, act, observe feedback, and infer rules, so it depends heavily on accumulating clues across many steps. OpenAI notes that evaluations rarely measure a model in isolation. They measure API settings, harness design, and prompting as a bundle. When the same model differs sharply across environments, do not assign the whole gap to the model version. Hold the task, input, tools, and acceptance criteria constant before comparing runtime environments. The human's first job is to rewrite "it got worse" as an observable failure, what was forgotten, repeated, derailed, or rejected. Chapter recap. First, performance comes from a model runtime bundle. Second, multi-step tasks depend on context continuity. Third, turn vague disappointment into an observable failure. Next, inspect reasoning continuity so you can see why action logs alone may still force AI to rediscover the task every turn. The original harness discarded private reasoning after every game action. The model could see past moves and short notes, but not the plans and insights behind them. That resembles a colleague keeping an activity log while forgetting the hypothesis they built one step earlier. The model repeatedly reinterpreted the environment, retried ideas, and struggled to turn early failures into a coherent strategy. In its response's API harness, OpenAI passed the previous response ID so reasoning could persist across tool calls and turns. With reasoning retained, the model thought less before each action while following more coherent strategies. Less repeated thinking was not the same as lower care. Your workflow may not expose private reasoning, but it still needs reusable task state, goal, verified facts, failed actions, open hypotheses, and next step. Chapter recap. First, an action log is not complete task state. Second, continuity reduces repeated interpretation and exploration. Third, humans define which conclusions must survive each turn. Then inspect long context management so you can distinguish blunt truncation from evidence-aware compaction. The original harness rolled away the oldest messages after history exceeded 175,000 characters, so early observations and actions gradually disappeared. Keeping only recent content is simple, but long tasks often place decisive clues near the beginning. OpenAI replaced rolling truncation with compaction, summarizing longer history before continuing so learned rules could survive longer runs. On this public task set, retained reasoning and compaction together produced roughly 3 times the score with 6 times fewer output tokens. Because both settings change together, these results do not isolate the contribution of each setting. Compaction is not a lossless archive. Critical constraints, failed evidence, and unresolved hypotheses belong in structured state with links to original records. When early evidence affects permissions, money, safety, or irreversible actions, a human must inspect the source instead of trusting only the summary. Chapter recap. First, rolling truncation removes early clues. Second, compaction should retain action-changing state. Third, high-risk conclusions still require original evidence. Now build a diagnostic order so you do not switch models, rewrite prompts, and add tools at once, then lose track of what actually worked. Step 1 freezes the model version, task samples, inputs, and acceptance rules to create a repeatable baseline. Step 2 checks context continuity. Did goals, plans, observations, failures, and decisions reach the next turn? Step 3 checks long task behavior, truncation, compaction triggers, summary rules, source traceability, and recovery. Step 4 checks runtime settings, complete tool results, timeouts, retries, concurrency, permissions, and state rights. Step 5 changes one variable for an A/B test using the same samples, while recording quality, cost, time, and error type. If context and runtime repairs still fail consistently, or the task exceeds the capability boundary, compare another model on the same baseline. Publishing, payment, deletion, permission changes, and high-stakes judgments still require human approval even when the metric improves. Chapter recap. First, freeze a baseline before changing variables. Second, diagnose context, long task handling, and runtime settings in order. Third, switch models only after stable failure or a capability mismatch. Finally, complete the model, context, runtime checklist so you have a reusable record for diagnosing AI performance. Box 1 records the baseline, model version, task samples, input, tools, acceptance criteria, and current result. Box 2 records context, which goals, plans, verified facts, failed actions, and open hypotheses survive each turn. Box 3 records long task behavior, truncation threshold, compaction trigger, summary rules, source links, and recovery. Box 4 records runtime settings, tool permission, timeout, retry, concurrency, state rights, and human approval points. Box 5 records evidence, the single changed variable and the same sample's quality, cost, time, and error types. Box 6 records the decision, repair the workflow, narrow the task, let a human take over, or compare a model on the same baseline. Keep the before and after configuration with every result instead of treating one impressive example as stable evidence. Screenshot this checklist and use it the next time your AI suddenly performs worse. Chapter recap. First, record a reproducible baseline. Second, inspect context and runtime settings separately. Third, use matched evidence to decide whether to repair or switch. To sum up, when the same AI agent performs worse, check context and runtime settings first. The same model can be amplified or suppressed by context continuity, truncation policy, and runtime settings. Externalize those variables so humans know what they are comparing. Freeze the baseline, change one variable, record the result, and keep human acceptance before high-risk actions. Which kind of sudden AI failure would you diagnose with this card first? Tell me in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.